Determine if the series summation n going from 0 to infinity of n plus 5 factorial over n times 4 to the 2n converges or diverges. Well, the first thing to notice about this series is that factorial. So there's no underlying function, but the ratio test can be applied. So let's go and write down our nth term, which is n plus 5 factorial over n times 4 to the 2n, and then use that to write the n plus first term, the consecutive term, which would be, let's see, n plus 1 plus 5 quantity factorial times n plus 1 times 4 to the 2 times n plus 1. And now let's clean this up. Up top we're going to have n plus 6 factorial, and on the bottom we'll have n plus 1 times 4 to the 2n plus 2. So the next thing we need to do is to work out the ratio of adjacent terms, an plus 1 over an. Now the formula for the n plus first term we just wrote down, that's n plus 6 factorial divided by n plus 1 times 4 to the 2n plus 2. Then we'll multiply by the reciprocal of an, so that would be n times 4 to the 2n over n plus 5 factorial. And now let's see if we can get some cancellations. The first thing to note is that these factorials can be canceled. N plus 6 factorial is n plus 6 times n plus 5 factorial. And so those cancel, leaving us with an n plus 6 in the numerator. Next, let's focus on these terms here. 4 to the 2n goes into 4 to the 2n plus 2, 4 to the 2 times. And so that's going to leave with a 16 down below. These remaining terms in pink don't cancel. So we have an n and an n plus 1. And so this will be our formula for an plus 1. It's n squared plus 6n over 16n plus 16. Now for the ratio test, we need to take the limit of the ratio of consecutive terms. So that means we're going to take the limit as n tends to infinity of n squared plus 6n over 16n plus 16. Now to take the limit of the sequence, this has a nice underlying function, so let's take the limit as x tends to infinity of x squared plus 6x over 16x plus 16. Notice that the numerator has a greater degree than the denominator, and so this will converge to plus infinity according to the leading coefficient test from Calc 1. That means this limit over here also diverges to plus infinity. Since positive infinity is greater than 1, kind of obviously, that means the ratio test says this series diverges. And so there's our answer. This would be a divergent series.